Let's take a look at the handout 36 on the venting guide for the codes for venting, and a little bit of a couple other little lessons in here. So I wanted to first start out about talking about the pipe types and the clearances typically. So the type B aluminum vent or aluminum type center vent system, it's got a galvanized outer layer as mentioned in prior lessons, but a type B with the aluminum center, typically it's 1 to 3 inches clearance, as with a type L or a BW. And normally the most common type of clearance from combustibles is basically a 1 inch. So that pretty much puts you at, if the outer diameter of the pipe happens to be, let's say 5 inches, then you would have to have a 7-inch opening at a minimum to maintain your clearances from combustibles by using some sort of a fire stop protective device. A type L is another type of a vent system that is referred to as having a stainless steel center instead of the aluminum inner lining. It has a stainless lining. It's designed to handle the higher temperature applications, such as with your solid fuel systems or your oil type systems. Typically L would be what you'd want to have, and they can be a galvanized outer layer, again 1 to 3 inch clearance. A type BW is actually a B vent that is wide, and it actually is an oval or kind of a semi-oval type of a vent system. They don't generally vent quite as good as a B vent because they're a little more restrictive just by the design of their vent system. But in a situation where you want to go up through an interior wall, or you have a wall furnace, or anything where you've got a really big time space consideration, and it's again, you still have to maintain those clearances from combustibles, but this provides you an opportunity to go from a round back to a BW and then back to round if you're trying to go up a wall and you're trying to utilize best practice. So that would be one possibility. Then of course there is single wall that is generally we would use this as our heavier gauge type. Usually minimum of 26 gauge would be bare minimum. There might be requirements where it could be a little bit heavier, but 26 gauge typically will be sufficient for normally your vent connectors, and that's really where you would mostly see that. So the problem with a single wall vent system is the fact that it has to have 6 inches clearance from combustibles on all sides. So that puts you at a very large opening size through a wall. It just makes it very prohibitive. So typically you would never ever see this run from a floor to a ceiling or anything like that. You're not going to run it through any of those. So we typically do not see that used at all. So let's take a look at the next section, vent connectors. So in this section here are vent connectors for multiple appliances. Those are, so first thing you'd have to identify is, which table do I want to use? And you have to identify, all right, which of the appliances and what are we dealing with? So generally it's, I put a note in here to go from page 145 all the way to 153 for the 2018 edition. They give you some examples in there as well. Don't exceed a lateral length of 1.5 times the connector diameter. So that's pretty much would mean if I have a 6-inch diameter of a vent connector, that you could go potentially up to 9 feet in lateral. If you exceed that, you're going to have to start derating tables, and so you try to avoid that. Most of the time that doesn't become an issue. Do not downsize more than what's allotted. So some of them will let you go down one diameter in size, and other ones you might be able to even go down 2 in some cases. So the rise, that would be the height that's measured from the draft hood outlet all the way up to the center line where the gas would go into the common vent. That would be considered as your rise height. And again, I would encourage everybody to go and look in the code book for some actual pictures that identifies this. So in this particular handout, we're trying to keep it small and short, and just a quick check to help people do this a little bit quicker. The tables also include two 90-degree elbows per appliance. So if you happen to have 3 elbows, then you're going to have to reduce the table values by 10%. And that would be for every additional, anywhere from 46 all the way to 90-degree elbows. Anything that would be 45 degrees or less, you would reduce by 5%. So that would mean that if you happen to have two 90-degree elbows and you happen to have a 45, you would have to derate it by 5% because the table already includes 2 90s. So you would, so for the 45, you'd have 5% reduction in addition to the table of values. And again, it's summative. So you would, if you had 3 elbows and a 45, then you would have to have, you would derate it by 15%. So whenever you're using the tables, always go to the shorter length for the vertical measurements. And you can interpolate. One of my handouts, handout 37, talks about interpolating venting tables and how do you do it. So I have an example in there on how to do it. It's really a straight proportional example of how to interpolate in between the table of values. So the other area to pay attention to is obviously whether you're dealing with fan minimum and fan maximum. So is it a fan assisted appliance or not, or if it's natural draft. So you just have to understand those things. If you're using a single wall connector, be very careful. You may have to consider a B vent if you're not going to be within those limit values. Most of the time the heat loss is so excessive in a single wall vent connector that it just doesn't allow you to do that. So you may have to say, all right, I want to do a single wall, but I can't. I'm going to have to use a B vent. So most of the time what people do is they'll run a B vent as far as they can go and then maybe have a little tiny short piece of the single wall to just get them connected. And you can still use the B vent as long as you keep it to a very minimal amount, and that should be. So as with all of them, make absolutely certain that the smaller appliance is the higher one, the point of entry and the common vent, and make sure you keep your pitching upward. The more the merrier on pitching as far as upward. You want to make sure that you're you're not fighting against the buoyancy of those gases. So the main vent, moving on to the next one here. So the main vent in single appliance system. So the height would always be measured from the connecting appliance to the top of the vent system where it exits the vent cap. So size it based on the total BTUs input of those appliances. And then the table, you can look at tables 13.1 for the direct connect. That would be basically a B vent going directly to the appliance. Would be the easiest way to do it, or direct connection would be one appliance. So identify whether you have single or double wall connectors. Good rules of thumb would be, to use, when you're going to use the tables, always go to the shorter length for vertical measurements. If you're trying to figure out whether I need to interpolate or whether I don't need to interpolate. And of course the longer length for the lateral would also function as well. So that would be a good way to look at this. Single appliance connector rules. A single wall connector, the lateral length cannot exceed 75% of the total height of the vent system as a general rule. And a double wall, you can go 1-to-1. So that's 100% for a double wall connector. Again, be very careful using single wall vent connectors with long laterals. So you're really going to run into problems where those appliances potentially will not vent correctly. So be very careful with that. Corrugated chimney liner. So I had one other handout that I had was a chimney liner handout, and that was handout 32. That particular, this is just kind of a ballpark corrugated ruling on this based on the code book. If you were to take the values in a non-corrugated liner and reduce those values by 20% of the listing, that would be for those restrictions. So you could essentially take what the value is for maybe a B vent and then reduce it by 20% if that were your liner you were putting into it, or it could even be a chimney in that case. So just be careful with that. But that's probably the easy way to do that. Just deduct it by 20%. You include one sweeping 90 elbow at the very bottom. It doesn't include the other one. So you still have a little bit more that you have to reduce as far as that goes. 13.1.13 2018, they talk about upsizing. Do not exceed the area of the collar size by more than 2 collar sizes. And the liner is needed in the existing main vent if you If you have two collar sizes larger than the appliance that you're venting into the main vent, the areas where you really have to be concerned, where you have to really concern yourself, is when you're dealing with smaller appliances that you're ripping out, and then or larger appliances you're ripping out that were common vented, and now you're left with a single appliance. You can oftentimes run into a problem where that vent size is so big now that it really will not vent correctly. So you have to really be careful with that. And then the last part of the handout describes terminations and dealing with the height as it exits and how close you have to be. So for your small systems, 12 inches in diameter or smaller, which is the majority of our systems, you can use the table 12.7.3 on 91 and to determine your minimum height exiting. And that's based on the pitching level of that application. The more you would have for vertical height as a general rule, usually you're benefited by that, since height and heat are the two most significant factors in the success of any type of vent system for that. So, but that's hopefully that's a little bit of a helpful guide on using the code book and understanding the vent tables.